Astronomers were taken by surprise in early July when they detected a strange and fast-moving object drifting through our solar system, an object that would soon be known as 3I/Atlas after further measurements confirmed that it was only the third interstellar visitor ever observed passing near the Sun. The discovery immediately sparked widespread scientific curiosity and debate, as interstellar objects remain one of the rarest and most mysterious categories of celestial bodies ever detected. Only two such visitors, Oumuamua in 2017 and Comet 2I/Borisov in 2019, had been identified before, and both of them left the scientific community with enormous numbers of unanswered questions. Now 3I/Atlas appears to be adding even more complexity to the puzzle. After its discovery, astronomers quickly noticed that the object was behaving in unusual and unexpectedly dynamic ways. Most notably, last week, as it reached its closest approach to the Sun, known as its perihelion, the object brightened at a rate far beyond what researchers had predicted for a typical interstellar comet. Even more intriguingly, its color shifted, becoming distinctly bluer in a manner that did not align with the usual behavior of dusty, icy objects heated by the Sun. These observations alone would have been enough to spark debate, but the situation grew even more remarkable when NASA's Jet Propulsion Laboratory revealed that 3I/Atlas was experiencing measurable non-gravitational acceleration, meaning its motion through space was not being dictated solely by gravity. To the average person, this term might immediately evoke images of alien spacecraft firing engines or using some form of propulsion. While astronomers do not rule out all possibilities, the scientific community generally leans toward natural explanations first. And in this case, the leading theory suggests that the source of this acceleration is mass loss. According to Harvard astronomer Avi Loeb, who has been following the object's behavior closely and has written extensively about it, 3I/Atlas is likely shedding massive amounts of material as it heats up near the Sun. He proposes that as the ice within the object sublimates, turning from solid to gas, it releases bursts of gas and dust that push back on the comet, creating a miniature rocket effect. This is similar to how traditional comets behave, but in the case of 3I/Atlas, the rate of mass loss appears unusually extreme. Loeb estimates that the object could shed something on the order of 1/10 of its total mass in just a single month, a staggeringly fast rate compared to what astronomers usually see. During a recent NBC News interview, Loeb explained that new measurements from the Atacama Large Millimeter/Submillimeter Array ALMA in Chile detected a deviation in the object's path, specifically a shift of 4 arcseconds in right ascension, compared to the projected trajectory. In astronomical terms, this is a significant displacement, one that strongly indicates an external force acting on the body. According to Loeb's calculations, such a deviation corresponds to an amount of non-gravitational acceleration consistent with the evaporation of roughly 1/6 of the object's total mass, a truly enormous percentage. With such a dramatic loss of material, scientists expect that in the coming months, specifically November and December 2025, when the object emerges from behind the Sun, it should be surrounded by an immense and highly visible cloud of gas and dust. Loeb predicts that observers may witness a plume containing as much as 5 billion tons of expelled material or even more. If these predictions hold true, telescopes around the world will be able to capture detailed images of this massive, evolving dust cloud, which will offer new insight into the structure and composition of interstellar objects. Loeb also points out that this mass loss could explain the object's unexpected brightening as it approached the Sun. A fresh release of dust and gas reflects more sunlight, making the object appear brighter from Earth. Ordinarily, a comet heats up and brightens in a somewhat predictable way. But 3I/Atlas has been anything but predictable, leading Loeb and others to consider alternative explanations alongside the natural ones. Despite favoring scientific conservatism, Loeb remains open to more speculative possibilities. He has long argued that Oumuamua, the first interstellar visitor discovered in 2017, displayed characteristics that could be consistent with an artificial origin, such as its extremely flat shape and its unusual acceleration. Now with 3I/Atlas showing a similarly puzzling non-gravitational boost, combined with its unexpected shift to a bluer color, Loeb has suggested that these phenomena could, in theory, be signatures of artificial technology. For example, he notes that ordinary cometary dust should make the object appear redder, because dust tends to scatter sunlight in a way that enhances red wavelengths. Instead, 3I/Atlas is becoming bluer, which Loeb suggests could potentially indicate the presence of an artificial light source or a hot internal engine. If the object somehow contained or emitted energy in a technological manner, such heating might cause it to shine more strongly in the blue part of the spectrum. Nonetheless, Loeb is careful to emphasize that natural explanations remain more plausible at this stage. One such possibility is that the blue coloration is caused by ionized carbon monoxide, a gas commonly emitted by comets when their frozen molecules vaporize near the heat of the sun. Ionized gases can produce vivid blue emissions. And if 3I/Atlas has an unusually high concentration of carbon monoxide or similar compounds, that could explain its unusual color without needing to invoke alien engineering. Even with all the unusual behavior, scientists do not expect the object's non-gravitational acceleration to alter its trajectory enough to pose any risk to planets in the solar system. Its path will remain largely similar to the gravitationally predicted one, and its visit will be brief before it heads back into the vast interstellar void. What is complicating matters significantly, however, is something entirely terrestrial: the ongoing government shutdown in the United States. According to Loeb, this shutdown has disrupted communication and delayed the flow of scientific information. He told NBC that he has been attempting to obtain observation data from NASA's Mars Reconnaissance Orbiter, which happened to pass by the vicinity of the object during its flyby near Mars, but he has not yet received any response from interim NASA Administrator Sean Duffy. Loeb expressed frustration over this, arguing that scientific data should not be withheld from researchers who are actively planning future observations. The sooner astronomers can analyze these reports, the better they can prepare for upcoming viewing opportunities when 3I/Atlas reappears from behind the sun. Without timely access to this information, scientists are forced to work with incomplete models, which limits their ability to fully understand the nature of this rare interstellar visitor. Despite these bureaucratic challenges, Loeb is determined to continue pushing for answers, stating that the scientific community must stay persistent in its efforts to study 3I/Atlas while it is still observable. Interstellar objects like this present a fleeting opportunity. They zip through our solar system once and never return, meaning every moment counts. For many astronomers, such objects are like messages from distant star systems, carrying clues about the chemistry, formation, and evolution of planets beyond our own. Whether 3I/Atlas proves to be a typical naturally behaving comet or something far more exotic, its passage will add invaluable data to our understanding of how objects travel between stars. For now, the world's observatories, researchers, and curious minds are watching closely, waiting for November and December 2025, when the object will once again come into view. Until then, the mystery continues, fueling debate, excitement, and speculation across the scientific community and beyond.